Okay, so let's study one. So how many of you know the term norm, NORM?
Kind of a distance measurement.
Kind of a distance measurement. Okay, fine,
EPT.
you can say, yeah. Okay, so definition. Okay, so um, without we will take our field to be R or C. So after maybe for after 2 days class we will everything do on RN, but I am doing something in one general setting, so that's why I am taking my field to be K or C, K or I mean RRC. So after 1 or 2 lectures we will totally uh, concentrate on RN. Okay, so let V be a vector space over K, a norm denoted by this or this is a function from V to 0 infinity, satisfying one. Okay, norm of x greater equal to 0 for all x is V, norm of x equal to 0 if and only if x equal to 0. 3, norm of alpha x equal to, for any alpha belongs to K, x belongs to V, for all. Okay, so is the definition clear to everybody, please?
Hello.
Okay, so um, mostly we denote norm by this notation. Since routine use this notation, so sir told me to strictly use this notation, so that's why I am using this notation. And whenever when you will learn function analysis, mostly you will see this for norm on any vector space, and this for scalars, like this mod
So
alpha.
I guess you don't need to write the first condition because you have already restricted
Yes,
the
yes,
domain.
yes. Yeah, that's some, I mean, that's superfluous. Don't need to write something like that. Okay, so given, okay, a vector space over k is called normed linear space if it has some norm, any norm, a vector space, no, let's write like a vector space v over k is called non-linear space if there is a norm on v, there is a norm on v. Observe, if v comma okay is a norm linear space, we can define distance metric by d of x comma y to be norm of x minus y. Check that d is indeed a metric. Okay, it is a metric, right? Hello. Okay. Okay. So show that okay, example, our familiar example, one R with Euclidean, what is R with Euclidean metric, Euclidean norm, absolute value C, where norm Z is defined as root under x square plus y square, where z equal to xy, z belongs to C. 3 Rn with, okay, so there are lots of norms on Rn. So you can ask me directly, you don't need to text messages. So translation invariant means, okay, so translation invariant, that is d of xy is same as d of x plus z for all z belongs to b. It doesn't matter, you translate this to point and you get the same distance with, okay, Rn. Okay, so let x equal to, not like that, x1 e1 dot 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 e1 to en a standard order basis of Rn. Define norm 1 I'm not supposed to use this. Summation xi square it is xi, yes, sometimes it is called sup norm. Okay, so here are some example. Okay, another one. 4, is it 4 or 5? 1 2 3 4. Okay, so how many of you know anything about compact metric space? You know, right? Compact metric space, compact topological space.
হ্যাঁ দাদা
Can define, let x be a compact topological space define such that f is continuous. Note that there is a natural choice of norm on Cx, which is any norm supremum x belongs to x if x. Okay, and why supremum exists? Hello.
Compatible.
continuous function of a complex topological space is bounded. So it doesn't exist.
Hmm. So this is a norm. Check all that. This is a norm. So these are some of the basic examples of nonlinear spaces. Now we move on to the next theorem. Okay. So is it true that every vector space has basis?
For finite dimensional case, it is true.
And what about infinite dimensional? Chandrei Sitama, please answer.
Do you know about Zon's lemma?
Stop.
Hamel basis.
Do you know anything except Hamel basis?
Zorn's lemma I know and Hamel basis I know. No.
Okay, what is Hamel basis? What is Hamel basis?
So natural basis, like
What do you mean by natural basis? So it is not an interview now, so you can answer confidently. So, what do you mean by Hamel basis? What do you mean by natural basis? Whatever you are saying, please define. Also participate Sitama, Obhinav, Anir, Piyash. What are you doing, guys? Please answer the questions. Yes, Chandri, what is Hamel basis?
একটু দেখছি, একটু দাঁড়াও, ভুলে গেছি।
In so now what I can say, I mean, at least every vector space has a basis. This is the first theorem you learn in linear algebra. Oh, that's a problematic part. Okay, so okay, so theorem. Let V and W be two non-linear spaces over K. Then and A V to W be a linear map. Then the following are equivalent. One is continuous and two is continuous at 0, 3. A is uniformly continuous. 4. Okay, let's rewrite it properly. There is a c greater than 0 such that five the set AB V belongs to V non V equal to 1 is bounded Yes, you can put it, you can remove it, no problem. The A is bounded for all bounded subset E of V. Okay, so we need to show that these all six statements are equivalent. So which implications are trivial? It's trivial. uh, what about 5 implies 6? How can we show that 5 implies 6?
Suppose E is a bounded set, then there exists some ball centered at 0 which contains C.
Yeah.
And that's how, if you take some vector from E, so you're taking a vector in Rn, and you can write it
No,
as
we,
some multiple of a vector which lies in the unit circle, right? Unit sphere, or
yes,
anything,
I mean
whatever you
you
would
are saying
say.
that take any vector E and bring it down to the unit sphere.
Yes.
Yes, then
And after that, we know that the distance from 0 would be less than some m. M is the radius of the giant ball which contains E and
yes,
centered at 0.
yes,
And we also know that the norm B is the norm AB is bounded. So that's how we know.
yes. So 1 implies 2 is trivial, 4 if and only if 6, and prove that. Okay, then then there are several easy implications, isn't it? A is continuous, A is continuous, 0 belongs to V. What about A is uniformly continuous?
Obviously, then 3 implies 2 and 2 implies 1. That would be trivial.
No, 2 implies 1, how? Okay, stop. Sritama, Chandri, please answer how 2 implies 1. Sritama, Chandri, please respond. We are taking this class only for you, guys. If you don't respond, there is no meaning of taking the classes.
I have a map check too.
I mean, both of us are wasting our times. I mean, if you are thinking, please respond. Please say that we are thinking on how.
Yes, I have
So how
yes.
are you thinking? What is your thought process? Please go ahead. There is no one to judge you. Chandri is in ISI Kolkata or Bangalore?
Kolkata.
Okay.
Uh, Let X not belong to
Which
X
implications
not.
you are proving?
I have assumed that A is continuous at 0
Okay.
and trying to prove that A is continuous on whole of V.
Okay. Okay. Go ahead.
So, yes, I have taken that X not belongs to V, and so X not will have a certain norm. So, say M, capital M, and X not by since A is continuous at 0, so there is a certain neighborhood of 0 for any epsilon greater than 0, there is a neighborhood of 0, there is there for which the continuity holds. So we take that capital M, uh, uh, for it has a norm. It's not as a norm set capital M, and for certain n greater than zero, that x naught by n will belong to that neighborhood of zero, uh, and
Can you please write and send it? Can you please write and send it the proof to the group, in the group?
trying.
All these things will be covered in 2 lectures in ISI, and be prepared for that. Okay, so okay, so we okay, so how many implications are left there? Hello.
We know 1, 2, and 3 are equivalent, 5, 6 are equivalent. So there is only 4. We need a bridge from 3 to 4 and 4 to 5. I guess that will be enough.
Yes. So how can you show that 1 implies 4? I mean 4 implies 1 is easy, right? 4 implies 1 or 4 implies 3 is easy. Can you see that?
Four implies 5 is also easy.
Yes, 4 implies 5 is easy. 4 implies 1 is easy, right? If it is continuous, I mean if 4 satisfies, then it is continuous. So we have to prove either 2 implies 4 or whatever, which implications you have to. So let's prove that. One, I am not proving these implications. 5 if and only if 6 are also easy. Let's prove. Okay, so what is 4? 4 implies 2 is easy. All these are left as an exercise. Now proof 2 implies 4. Suppose what is 2? 2 is continuous at 0. Yes. Suppose, okay, so is continuous at 0. Let epsilon greater than 0 be any. Since is continuous at 0 for this epsilon, there is some delta such that whenever norm v less than delta, this implies norm of f is less than epsilon, right? This is the definition. Okay, take any v belongs to v and non-zero, then V by norm V. I am again. So what is the norm of V by norm V? Hello. What is the norm of V by norm V? No response.
Norm of capital V by this norm.
Sorry, what are you saying?
Both are small letter V.
Yes, both are small v. Since what is the norm of y? Norm of y is norm v by 2 norm v delta is equal to 1 by 2 delta. No, not here. Delta by v. No, delta v. Half delta by v norm v by non v. It is delta by 2 less than delta. Therefore, ay less than epsilon. This implies what is a norm of a, what is y? Y is a delta v by 2 norm v. This is less than epsilon. Okay, so using linearity of a, delta comes out, 2 comes out, norm v comes out, av remains less than epsilon. This implies norm of av less than epsilon delta by 2 norm v. For all v belongs to v, therefore we may take c to be epsilon delta by 2. Okay, the proof is clear. Hello, is the proof fine? Disgusting.
Have you multiplied it right?
Sorry,
Delta by 2v, and you are multiplying what? Both sides? Is
no,
it epsilon 2 epsilon by delta or what?
okay, am I
Or am I making some school level mistake?
I may have made mistake. No, 2, no, I may have made, yes, it's my mistake. 2 epsilon by delta, yes. Is it fine then?
So is it unique or not?
Of course not. Of course not. You may take any number greater than this. What do we have? 2 epsilon by delta. So, okay. So, we have proved. Okay, so what remains? 5m plus 4, right? What is 5? 5 is saying AV is bounded. We need to show that this. Okay, fine. AV is bounded for all V equal to 1. Since the set AV, V belongs to V, non V equal to 1, is there is bounded, that is AV less than M for all non-V equal to 1, there exists M greater than 0 such that this holds, right? Choose any 0 not equal to V belongs to V, then Vy non-V is, then A Vy non-V, this modulus is less than M. This implies AV M mod V for all V belongs to V. Yeah, fine. Done. Okay? So, what is definition? Let V be a non-linear spaces and over K. We say we say norm 1 is equivalent to norm 2 if there are C comma D greater than 0 real number. Yes, I am saying greater than 0 means real number, such that C norm 1 lesser equal to norm 2 lesser equal to D norm 1. Note that
Can you please go to the previous page?
Yes, someone is saying something.
Yes.
Is the definition fine?
We must simply take one variable, right? Take C and 1 by C. Looks better.
C2
C and 1 by C.
C and 1 by C. Does this imply that
It should work. It's an exercise of Kumarasana. It should work.
so if two norms are equivalent, if there is C
Then there
and
exists some C such that C norm 1 less than equal to norm 2 and 1 by C.
lesser equal to 1 by C norm 1.
Yes, there is some exercise.
Okay, let's think about that. Okay, so we'll think about it. Okay, so theorem.
Or it would be better if you write C is replaced by 1 by D. It would be better, I guess.
Okay, okay, no problem. Any two, uh-huh, it is C is replaced by 1 by D. Any two norm. Is it fine now?
Yes, it is.
Any two norm on a finite dimensional vector spaces are equivalent. Okay, so do you know the proof? There are several proofs. Any two norm on a finite dimensional non-linear spaces are equivalent. I not say vector spaces is non-linear space. Okay, so any idea how to prove it? Please respond. Obhinovo, are you there? Anit, Piyash, are you there?
ভাবছি।
That's the best answer I can get.
আচ্ছা, ওই যে উপরে যে রিলেশনটা তুমি বললে ইকুইভ্যালেন্ট নর্মস এর জন্য, ওটা যদি সামহাউ বেসিস এলিমেন্টস গুলোর জন্য দেখিয়ে দিই, তাহলে বলতে পারবো কি?
Yes, what is your problem?
ওই যে তুমি যেটা বললে না যে সি ইন্টু নর্ম ওয়ান লেস দেন নর্ম টু লেস দেন ডি ইন্টু নর্ম
Oh, this one.
ওয়ান।
Okay, okay,
ইয়েস,
okay. Yes.
এটা যদি ভেক্টর যেহেতু ফাইনাইট ডিমেনশনাল,
No, I never say infinite dimensional. Let
না না
V.
মানে যেটা প্রুফ করছি আর কি, থিওরেমটা,
Oh, oh, okay. This one. Yes.
এটা যদি সামহাউ বেসিসের এলিমেন্টস গুলোর জন্য দেখাতে পারি ওই রিলেশনটা,
Is
তো সেখান
is
থেকে
norm
বলতে পারবো।
is norm a linear map? No, it is not, right? It is uh, sub-additive. It is not additive. It is sub-additive.
হুম,
So you can't say that.
ও আচ্ছা, আচ্ছা।
Hmm. Okay. Let b equal to let b okay, so let v be basis of v. So any belongs to V can be expressed uniquely as V equal to C1 V1 Cn Vn. Define norm V maximum okay V okay let be any other norm, then norm V norm summation CIVI severity property and triangular inequality, that is severity VI is lesser equal to okay, so is it clear?
आगे पीछे बोल सर.
Yes.
Clear sir.
Is it clear?
हाँ.
So take okay C to be this summation I equal to 1 to n on VI. This implies non V is lesser equal this of course greater than 0, of course greater than 0. So C this. Now we need to show that reverse inequality. How can you show that? Set Vj is this span remember what is if this is V1 to Vn are basis element, I am setting Vj to be this set. Okay, so if I have norm V, this can be written as summation CIVI I ranks from 1 to n. This is okay, I am okay C okay Cj Vj plus I runs from 1 to n CIVI j not equal to I. Put Cj out, it's Vj plus 1 by Cj I runs from 1 to n j not equal to I CIVI. So this is greater equal to Cj Vj plus no not like that. is this part Cj I transform 1 to n Civi j not equal to I. Now this whole thing greater than distance of Vj right?
He is coming from where?
Sorry,
He কোত্থেকে আসছে স্মল বিটা?
very small v. So small v is any vector in V. Okay. So for V is in V.
তাহলে সিজেটা যে নন জিরো তুমি কি করে জানছো? যে সিজেটা দিয়ে যে ভাগ
If it is
করছো?
not, if it is non-zero, oh, so if okay, nice. Mm, yes, you can say that if it's non-zero, how can I divide it by? Hmm. Mm, okay. Okay, no problem. Okay, no problem. You can write it like this. You can still write it CJVJ.
ফর সাম এর জন্য করতে চাইছো নাকি?
I am doing for some j and then I will do for all. In the I am
না না,
taking
এটা যে যে নন জিরো হয় তাহলে তো মানে ফর সাম সিজে ইট উইল বি নন জিরো, রাইট?
just a minute, just a minute.
কোনো একটা সিজে তো
No, no,
তোমার
no,
নন
no,
জিরো হবে, নাহলে বিটা তোমার নন জিরো কি করে হবে?
no,
এটা
no.
কি তুমি বলতে
Yes,
চাইছো?
yes, yes, but no, no. I am not going on that line. Yes, you are right, but I am not going that line. J not equal to I, Civi. So, okay. So now this thing, can I write it? CJVJ. It is greater equal to CJVJ and what is Vj? Can I write it? Is it okay, right? Hmm. This is basically D. This is basically this distance between this and this. Now, can I write it?
এই স্টেপটা একটু ভেঙে বলবো,
Which one?
দিস লাস্ট স্টেপ,
This from
লাস্ট
this or
স্টেপ
this from this?
ইয়েস,
This,
নো নো,
this. Yes, I am
Yes.
asking, can I write it or not? But when I can write it? Yes, certainly I can write it when Cj not equal to 0, but not every time. If V is not equal to 0 element, then there is some j for which Cj not equal to 0. I can surely do that for that j.
I understand.
sorry.
Can you just elaborate a bit?
Can you repeat?
Can you please elaborate a bit this last step?
Yes, I am asking that. Can I write it or not?
তুমি লাস্ট দুটোই জিজ্ঞেস করছো নাকি শুধু লাস্টেরটা জিজ্ঞেস করছো?
লাস্টেরটা না, এই 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 জিনিসটা তো ঠিক আছে, এই জিনিসটা তো ঠিক আছে, রাইট? দিস ওয়ান ইজ ফাইন.
কেন ওটা ফাইন কেন? আমি স্টেপ যা বুঝতে পারছি না।
নো, ডেফিনেশন কি? ডি ডি অফ এক্স কমা ওয়াই ডেফিনেশন কি? ইনফিমাম অফ ডি অফ এক্স কমা ওয়াই, y belongs to v, right? So I am putting some particular element here. So this distance must,
ও আচ্ছা, ওটা ক্যাপিটাল ভি নিয়েছো তুমি?
which one? This is capital Vj. This is, oh, you are, oh, it is small vj, it is small vj, it is small.
তোমার স্মল আর ক্যাপিটালের মধ্যে তোমার পার্থক্য কি বোঝা যাচ্ছে না? আমি ভেবে যাচ্ছি কন্টিনিউয়াস, ওটা হয়তো তোমার স্মল লিখে গেছে হয়তো।
No, 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 you should interrupt them.
অন্য কিছু দাও, অন্য নোটেশন দাও, ওই ক্যাপিটাল ভিটাকে অন্য কিছু লেখো তুমি। ডাব্লিউ ডাব্লিউ কিছু একটা লেখো।
No, now it is fine. Now these two are fine. I should write, okay. So this one is fine. I am saying, can I write this one? Then I will take in, I mean,
ঠিক আছে, ওটা ঠিক আছে, ওটা ঠিক আছে।
this one, pulling the CJ out. And there is no meaning if CJ is 0. If CJ is 0, the whole thing goes into VJ. So it is automatically 0. Right? Ayon?
Please can you say the meaning of small and capital V once more?
No, small, capital VJ is this set, this vector space. The small and the small ones are elements of basis.
Oh, okay.
V1 to
তুমি
Vn
কি
are,
ডিসটেন্স বিটুইন সেটটাকে ডিফাইন করেছো?
which one? This?
তুমি হ্যাঁ আবার ডিফাইন করে দাও, এটা ভালো হবে।
Okay, so distance between this, okay. Okay.
পয়েন্ট টু সেট আর সেট টু সেটটাকে ডিফাইন করে দাও, একটা পাশে একটা বক্স করে ছোট্ট নোট করে লিখে দাও।
Okay. Okay, so there is a catch. There is a catch. What do you mean by distance between a point and set? So there is hell lot of metric on, there is hell lot of metric on that vector space, that non-linear space. One is this, one is I defined a norm, I am working with another norm, so we at least have two different metric on this space, and there is lot more. So what do you mean by this distance? I am saying that the distance is with respect to this norm. There is a, so that's the catch. Okay, so I am explicitly mentioning what do you mean by this, comma Vj. This means infimum Cj Vj minus y belongs to Vj. Okay, so now it is clear.
না, পি আর থিটাটার মধ্যে পার্থক্য বোঝা যাচ্ছে না।
এখনো বোঝা যাচ্ছে না?
থিটা মনে হচ্ছে ওটা, আর এই ক্যাপিটাল ভিটাকে ভালো আমার একটু বড়, বাই চান্স কেউ নোটটা দেখলে পুরো একদম মিস করে যাবে।
Now it is fine. So I am saying that if Cj is 0, then it is anyway 0. So this equality holds. If Cj is not 0, I can pull it outside. Now, so I have this, right? Hello? Ayon? Hello, Ayon?
হ্যাঁ বলো।
So what I am saying is if Cj is 0, then this inequality is trivially true.
হুম
So I can't do anything. If Cj is not 0, I can pull the Cj outside.
ওকে
So suppose if, okay, so what I can say that so I can do for that j for which Cj is not equal to 0, and then I am taking infimum over all j, right? So if I take infimum over all these elements, all I have, if I take infimum over all these elements, then for those j is Cj is non-zero, it will appear in the equation. Other then and rest of them are 0, so I don't have to take care anything. So if
Please write that statements
so if we
one at a
take,
আচ্ছা ইনইকুয়ালিটিটা হচ্ছে নাকি ইকুয়ালিটিটাই হচ্ছে, কারণ সব তো পজিটিভ আছে, আর সিজেটাকে তুমি যদি বাইরে
yes,
নিয়ে নাও
it
তাহলে
is
তো
equal, it is indeed equal, but I am writing inequal. Okay, if you want, yes, it is equally actually equal.
সেট দুটোর আলটিমেটলি তোমার কোইনসাইড করে
Yes,
যাচ্ছে, তাহলে
yes,
ইনফিনিটি তো করতো না।
it is actually the same set. If Cj is not equal to 0, then it is same set. If we take over j, 1 lesser equal to j lesser equal to n,
জিরো হলেও তোমার সেম সেটই হচ্ছে দেখো,
huh?
কারণ তুমি সিজে থেকে যদি তোমার জিরো হয় তাহলেও সেম সেট হবে।
Huh. Now if I take infimum over this set, that vj say this a, then what we have, then non v is actually greater equal to a times this is greater than this is greater than 0. I mean, if this is strictly greater than 0 when v is non-zero, this is strictly greater than 0 when v is non-zero. If v is 0, then there is nothing to prove, nothing to do. We can only say if v is non-zero.
which is strictly greater than zero.
If this a is strictly greater than 0, if v is non-zero, right? If v is 0, then it is 0. If v is non-zero, then it is greater than 0.
V is non-zero or the V is lying in Vj. Which one are you talking about?
Okay, for that it is also 0. For that it is also 0.
না না ঠিকই বলছো, এটা জিরো হলেই হবে, কারণ যে তুমি রানটা তো জেতে করাচ্ছ না, আমি ভুল করে ইয়ে দেখছিলাম। না না ঠিকই বলেছো, V
So
যদি জিরো হয়
I
তাহলে
mean
জিরো হবে না।
for some particular j0 it is 0 for j0, but for rest of them it is non-zero, right? So
হ্যাঁ ঠিকই বলছো।
it is fine, right?
হ্যাঁ
So then what we have? Then we have this, na? So we prove the reverse inequality. We need it. This is non v. This is greater equal to. If I take infimum over j, so yeah, we are done, right? Just a minute. Is it correct or not? It is maximum ci, so I want maximum here. So if I I take infimum or it is supremum? It is infimum works, right?
কাজ তো করছে দেখছি।
Yes, infimum works. So we establish the reverse inequality too. Therefore, norm, this is A. No, what we have? AVV. Okay, so AVV less or equal to what I have. Why? Okay. If it is A, then put it D here. It is D. It is C. For all V belongs to V. Okay. So we have proved that uh, for a particular basis, so VB is equivalent to any norm. So if you take, so now you can check that the collection of all norm on a vector on a nonlinear space, if we give the relation that A is related to B if and only if A is equivalent to B, then this is a equivalence relation. So you have the result. So the proof is complete.
Can you say what you said just last
So
line?
I am saying what we have proved. We have proved that this is an arbitrary norm, and this is and for some basis B, this is a particular norm. So we have
Yes.
we have shown that these two norms are equivalent. So this is another norm. So these two norms are also equivalent. So now I am saying that these two norms are equivalent. It is
Okay,
just,
transitive relation.
yeah, transitive relation. I am just saying that if we collect all the norms on a vector nonlinear space and put a relation that A is related to B if A is equivalent to B, I mean they are norms. So this is an equivalence relation. So from there it holds. I am saying that if you have these two, you can prove that. So the proof is complete now. Fine.
Yes.
Okay. So okay. Proposition. Let V be a finite dimensional non-linear space and W be any non-linear space if a V2W is any linear map then A is continuous. Do you know this result? That any linear map on a finite dimensional space is continuous? Hello. Okay. So we prove that. Okay. Define norm V for V belongs to V. Okay. For V belongs to V, define non v dash. I am saying that it is norm of AV plus norm V. Check that this is a norm. Is a norm on V. Since this since V is finite dimensional, by previous theorem, are equivalent, that is there are c comma d greater than 0 such that c non v prime lesser equal to non v lesser equal to non d norm v prime. Okay, so let's see which side works.
That theorem is if and only if theorem.
Which one?
Uh, we have learned that if there exists such C and D, then the norms are equivalent. But if norms are equivalent, then there exists such C and D.
This is the definition, right?
Oh, sorry.
Okay, so non v, let's try this side. What is non v dash? It is norm AV plus norm V. Okay, so okay, 1 by d non V lesser equal to no, this side will not work, right? No, this side will not work. This implies C into AV plus V lesser equal to non V. AV plus V lesser equal to 1 by C non V. AV lesser equal to 1 by C minus 1 non V. Okay. Hmm. Okay, so it can be negative. This proves for all v belongs to V. This implies A is continuous.
How do you know that C is less than 1?
Okay, I I think it comes automatically. I don't have to do anything.
I guess here you need a statement I have told before.
So you are saying we need this.
We need 1 by C and C. That's why
We need this.
yes.
We really need this. I mean, if this is, see this, if this is negative, then this becomes negative.
Then we arrive at a contradiction.
Yes, so this can be negative.
But we
I
have
mean,
not assumed anything wrong. So from where the contradiction is coming?
this this always holds, right? If v is non-zero, divide it. Okay, okay, if v is non-zero, we can divide it. So this fine, this is fine. 1 greater equal to 1 by c. Is it fine now?
How how is this holding like?
Sorry.
মানে করলেটা কি আমি সেটা বুঝতে, তুমি জিরো থেকে তুমি পজিটিভ হলে তুমি বলছো যে মানে কিন্তু আমি তো এটাই বলছি কন্ট্রাডিকশন হচ্ছে।
No,
তুমি
this
সেই
this
একই
quantity,
জিনিসটা নিয়ে প্লাস উল্টো দিকে চলে গেলে
no,
তুমি।
this quantity
তুমি
is
এটা
always positive.
হ্যাঁ আমি আমার তো কথা হচ্ছে সেটাই যে সিটা যদি নেগেটিভ হয়ে যায় তাহলে আমরা কন্ট্রাডিকশনে আসছি যে তোমার পজিটিভ জিনিসটা নেগেটিভের থেকে তোমার লেস দ্যান ইকুয়াল টু হচ্ছে। এটা তো আমি কন্ট্রাডিকশন কনক্লুড করলাম, তুমি ওই স্টেটমেন্টটাকে ধরেই আবার প্রুভ করে দিলে।
Sorry, just a minute. Hmm. Okay. So if we have c and 1 by c, then we have no problem.
ওটাই তো বলছি, ওটাই তো বলছি। 1/c টা c এর চেয়ে ছোট হবে।
সেটা নাও হতে পারে, সেটা যদি 0 থেকে 1 এর মধ্যে থাকে তাহলে
কেন হবে না? কেন হবে না? আমার স্টেটমেন্টে যাও, আবার স্টেটমেন্টে যাও। স্টেটমেন্টে এবার তুমি আরে একটা কি হলো না, তুমি চলে যাচ্ছ কোথায়? এই তো, আরে এইটা না, এইটা না, এটা তো বোঝাই যাচ্ছে না, ইনইকুয়ালিটিই তো বোঝা যাচ্ছে না তোমার। আগেরটাতে যাও। এবার ভাবো তুমি সি এর জায়গায় 1/d ভাবো,
হুম
দিয়ে বলো আমাকে ডিটাকে কেন গ্রেটার দ্যান 1 হতে হবে। লেখো লেখো, ওরকম ইয়ে করো না।
c এর জায়গায় 1 by d, মানে ডিটা সবসময় 1 এর থেকে বড় হবে। হুম? ডিটা 1 এর থেকে ছোট হলে কি সমস্যা হচ্ছে? Just a minute. ডিটা একের থেকে ছোট হলে কি সমস্যা হচ্ছে? Let v comma non-linear spaces and a v2w be a continuous linear map. Norm of A is defined to be supremum.
দাদা,
Hmm.
সিটা যদি তোমার লেস দেন 1 হয় তাহলে তোমার ওই মিনিমাম নিয়ে আবার কাজ করতে হবে। আমাদের মিনিমাম অফ ডি নিতে হবে, আর ডিটাকে 1/c তে ইয়ে করতে হবে, তাহলে কাজ করে যাবে।
আচ্ছা, তাহলে ওইটা একটু কালকে পরের দিনের জন্য দেখি।
হ্যাঁ, ওটা একটা কাইন্ড অফ এক্সারসাইজ দিয়ে রাখো, বা প্রুফ অর ডিসপ্রুফ হিসেবে দিয়ে রাখো, যে ওই সিডিটাকে সিতে করা যাচ্ছে কিনা,
কেউ
আর ওটা
করবে
ইউজ
না,
করে
কেউ করবে না, আমাকে করতে হবে, কারণ আমার প্রুফটা আটকে গেছে, সেই জন্য আমাকে প্রুফটা তো সারাতে হবে কোনো রকম ভাবে। তো আমি যেটা পরের দিন দেখা যাচ্ছে। ওকে, সো if v and w be two non-linear space and a is a bounded continuous linear map on a v2w, then we define norm of a to be this quantity, this supremum of av norm av by norm v not equal to 0, v belongs to v. Okay, so this is finite, right? This quantity is finite. Check that vw
এটা তো শুধু এবি হবে না, such that norm equal to 1।
সবকটা একই, ইকুইভ্যালেন্ট।
ও হ্যাঁ, সেটা
Okay, so no, okay, so this is a subspace. Check it, it is a subspace, it is easy. So to check it is a subspace, so that defines a norm okay, so it is, no, to prove it is subspace we don't need to show anything. Check that it is subspace, show that norm defines a norm on BVW. This is an exercise. Okay, so তুই যেটা বললি যে ওই এই যে এইগুলো আর কি, যে norm is same as supremum av v belongs to, okay, not এরকম লেখা যায় না, supremum av
হ্যাঁ এটাই।
এই সবকটা কোয়ান্টিটি সেম হয়, তো এটা আমি এখন এখানে করব না, এটা ওই এক্সারসাইজে করবো আর কি। কারণ ওখানে কিছু অঙ্গ ঠঙ্গ তো করতে হবে, এখন সবই এখানে করলে তো মুশকিল হয়ে যাবে। স্যার আমাকে এমনিও তো মানে স্যার এগুলো আমাকে করতে বলেনি, আমি করছি আর কি জিনিসটাকে একটু হালকা করার জন্য। ওই রুটিনে শুরু করলে এতক্ষণে হয়তো চেন্ডুল ঠেন্ডুলে ঢুকে যেতাম। তো এটা আমি এখন করছি না, এটা এক্সারসাইজ করব যখন, তখন এগুলো এটা 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 প্রমাণ করব। পাশাপাশি রাখি। ওকে, সো so is any finite dimensional non-linear space complete? Hello?
Can you repeat the question once?
Is any finite dimensional non-linear space complete? Is Rn complete?
Yes.
How do you prove that?
Every Cauchy sequence converges,
Yes.
and the convergence we can show it with the help of node.
Okay, I mean, please share your idea. How can you prove that? Let's prove for R2. Can you prove that for R2?
Try.
Okay, so
No, I can't.
sorry.
বাড়ির উপর।
Okay, so so for this problem, first we will work with this norm, then we transfer to any other norm.
হয়নি বাবা, একটা বাজে।
Okay, the Cauchy sequence on V.
So it would be isomorphic to Rn or Cn, right?
Yeah, it is isomorphic. I mean,
Depends on the field, and
in
since the
which
linear
sense?
transformation is uniformly continuous, so
You
it
can
matches
say that. You
basically
can,
to.
yes, yes, yes. Yes, then I think you need to either prove Rn is complete or any finite dimension harmonic space complete, or
So
Cn.
R is complete is enough, because if we can prove R is complete, then Rn is complete, right?
R is complete, then I mean you need to prove that. Yes, it is true, but
So it is enough to prove that R is complete.
R,
So let us take a Cauchy sequence in
we
R.
prove that R is complete. What about R2 or Rn? We prove that.
So if a sequence is Cauchy, okay, then the component sequence, suppose the sequence are, write a sequence in Rn first. First write a sequence in Rn, then
Yes, yes. Tell me.
একটা লেখো, সাপোজ লেখো না, একটা সিকোয়েন্স লেখো, A1, A2, ডট 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 an, ঠিক আছে, আর মাথায় তার একটা m দিয়ে দাও বা k দিয়ে দাও। হ্যাঁ, এবার এই কেটা আমার ওই সিকোয়েন্সের নাম্বার ও ইন্ডেক্স গুলোকে রিপ্রেজেন্ট করছে, যেরকম x1 x2, সেটাই হচ্ছে এই কেটা, ঠিক আছে। এবার যদি এই সিকোয়েন্সটা কনভার্জ করে আরএনএ, তাহলে আমি বলছি যে A1 কে, সরি, A11, A12, মানে নিচে 1টা আছে কনস্ট্যান্ট, আর উপরে কেটা রান করতে থাকে। এই যে সিকোয়েন্সটা পাবো, এটা তো আমরা আরএ পাবো,
Hmm.
রাইট?
Hmm.
তাহলে এই সিকোয়েন্সটাও কচি হবে, আর
Hmm.
যেহেতু আর কমপ্লিট, এটা কোথাও একটা কনভার্জ করবে।
Hmm.
এবার সেই পয়েন্টগুলো কালেক্ট করো, দিয়ে প্রুফ করো যে এটা ওই মানে যে পয়েন্টটা আমরা পেলাম সেটাতে কনভার্জ করছে।
সেটাই করবো।
দিয়ে এবার লিনিয়ার ট্রান্সফরমেশনের থ্রুতে তুমি এটাকে আনো, দিয়ে দেখো যে হ্যাঁ এটাও করবে। ইউনিফর্ম কন্টিনিউটি খুবই একটা ক্রুশিয়াল জিনিস, কিন্তু এখানে যদি ওটা না থাকে তাহলে জিনিসটা কিন্তু ট্রু না। যদি ইন জেনারেল আমাদের কাছে একটা হোমিওমরফিজম থাকে দুটো স্পেসের মাঝখানে, তাহলে একটা সিকোয়েন্স কচি হলেও কিন্তু তার ইমেজটা কচি নাও হতে পারে
Hmm.
বা কনভার্জ নাও করতে পারে।
Yes. Hmm. C in M VM. Okay. So XM Cauchy means since XM is Cauchy implies for each epsilon beta there such that norm of xn minus xm less than epsilon whenever yes. So this implies uh, uh, no, not m prime. So xm minus xm prime is supremum equal to supremum কি এক মিনিট সি yes c jm minus c j maximum 1 lesser equal to j lesser equal to n, it is less than epsilon. So this implies cjm prime minus cjm, so less than epsilon for all 1 to n. cjm m is Cauchy in K for all j. Complete. cjm converts to dj, j equal to 1 to n. Claim x equal to no, d1 v1 dn vn claim
একটু ওপরটা দেখাবে।
xm converges to x. Yes, দেখাচ্ছি where x equal to 1 d1 v1 plus dot dn vn.
হয়ে গেছে।
ঠিক আছে, এবারে এক্সএম এক্সে কনভার্ট করছে। ওকে, let epsilon greater than 0 be any, since CJM M converges to DJ for all j, CJM minus DJ এখানে একটু সমস্যা আছে, less than epsilon for all m greater equal to nj and for all j equal to 1 to n. Okay, take into maximum nj then CJM minus DJ less than epsilon for all m greater equal to n. This implies maximum CJM DJ less than epsilon m. This implies xm minus x. This norm is less than epsilon. This implies xm converges to x. Done. প্রুফটা ঠিক আছে? ওখানে এটাই বলছিলিস তো নিশ্চয়ই?
হ্যাঁ এটাই বলছি।
প্রুফটা ঠিক আছে?
হ্যাঁ হ্যাঁ ঠিক আছে।
আচ্ছা, এটা তো গেল যে পার্টিকুলার একটা নর্ম নিয়ে। এবারে যে কোনো নর্মের জন্য কি হবে না, যে কোনো, এবার আমরা জানি যে কোনো দুটো নর্ম ফাইনাইট ডাইমেনশনাল স্পেসে ইকুইভ্যালেন্ট, তো সেই জন্য কোনো একটা নর্মে কনভার্ট করলে কোনো একটা নর্মের কজা সিকোয়েন্স হলে অপর নর্মের কজা সিকোয়েন্স হবে, তো সেইখান থেকে বাকি পার্টটা করা যাবে। আমি এটা পার্টিকুলার নর্মের জন্য করেছি, এখন বাকি পার্টটা ওইভাবে করতে পারবে যে অন্য কোনো একটা নর্ম নাও ইকুইভ্যালেন্ট হবে, তো ওইটার আন্ডারে কচি হলে ওটার আন্ডারে কচি হবে, এটার আন্ডারে কনভার্স করলে ওটার আন্ডারে কনভার্স করবে। আজকে আর বেশি টানবো না, প্রথম দিন এতটাই থাক।